Hi, welcome to Chapter 14. Chapter 14, we're going to get into kind of the meat and potatoes of what programming is all about in this modern world, and it's something called object-oriented programming. And so, again, since we're dealing with pseudocode and flowcharts, we're going to stay more at a conceptual level, but we're going to we're going to get kind of get into the nuts and bolts of programming. Um, this should go straight into when you basically grasp these concepts, you should be able to take them right into Java and be just fine. So, six different sections we're going to cover today. We're going to actually get into what a object is. We're going to talk about classes. We're going to use this thing called, or discuss this thing called Unified Model Language, which is called UML, and think of that as kind of a flow chart. Well, not really a flow chart. It's flow chart like on how to describe a class. So when we do our documentation, we would basically use a UML to document our classes so that when we were to issue those into production as a production program running, and this would be the documentation we'd have file away. How to find classes and the responsibilities in a problem. Inheritance and polymorphism. These are really two huge things that make object-oriented programming very powerful. So, okay, so let's get into it. So, let's talk about what an object is, okay? And I'm going to kind of bypass a lot of this first part here. Here's what I want you to think about. I want you to think about an object. We've kind of sort of dealt with objects up to this point, and what I mean by that is some of these different built-in functions, those are object-like, meaning they've already been created for us, we just get to use them. So an object is just that. An object holds data, and then it has its own methods to basically execute things. Now, a lot of times, an object is what I like to call a black box. I can load data into it. I can then call some of those methods within it, but I can't actually see the code. So it really is truly this black box sitting there. I load data into it. I call the different methods. I get back the correct data, and boom, that's how it works. So I want you to think about this. I want you to think about an employee object. Okay, the employee object is going to have some holders of data, and those holders of data are what we call fields. We're going to have a first name field, last name field, city, state, zip. We're going to have hourly rate. We're going to have hours worked. We're going to have number of dependents. We're going to have all of those things needed for a paycheck. Then we're going to have these methods. Now, these fields we aren't going to have direct access to. Okay, we never have direct access to the fields. We have direct access to those fields through the methods. We're going to have a method that basically says set first name. So when I pass first name into that set first name method, it sets the field for us. And I'll get more into why we do that here in a little bit. So I then set all of those fields. Once those fields are all set, I can then say, I can call the federal income tax method. I call the federal income tax, it gives me back the federal income tax. How did it get there? Well, it got there because it knew hourly rate, it knew hourly the hours worked, it knew the FICA, it knew exemptions, it knew all that, and was able to do that calculation and return the federal income tax to us. We could have a return gross pay. It calculates the gross pay. We can then say return the net pay, and it returns the net pay. And that could all be done inside of the employee class. Again, we don't know what's inside there. We don't care. We just know that when I throw it these fields, it will return this data. And that's basically what an object is all about. Is basically it holds data and it can return data that we basically, and it will do calculations and do all that. Okay, so let's talk about, so the very first thing it talks about is we've got an everyday example of an object. This is an alarm clock. So it has the following fields: the current second, the current minute, the current hour, the time the alarm is set for, and whether the alarm is on or off. So those are what, basically five fields. So seconds, minutes, hours, the alarm set, and then is the alarm on or off. Okay. So, be able to set those fields, we're going to have set time, set alarm time, turn alarm on, and turn alarm off. Now, set time, what do you think that's going to do? That's probably going to set the seconds, minutes, and hours. And set the alarm time is going to basically do what the fourth step is in of that bullet. It's going to set the alarm when the alarm is supposed to go off. And then we've got two switches: turn the alarm on, turn the alarm off. Okay. The alarm clock also has private methods. Now, private methods are, okay, here's what you think about. We have private and public. Public, everybody can see outside of the object itself. Private can only be seen within the object. So if I have the second, hours, and minutes, those are going to be set to private. Means I cannot access those directly outside of the object. The way I get to them is through this set time. So my set time method, since it's inside the object, it has direct access to those fields. So when I say set time and I give it a specific numeric value, it will go ahead and set the seconds, hours, and minutes. Okay, and so what'll happen is so that set time is a method all by itself. Okay, again, we do not have direct access to minutes, seconds, hours, set the alarm time, and the switch to turn the alarm off or on. We don't have direct access to those. We have access to those through the methods. Since the methods are inside of that object, they have direct access, because again, those are marked private. We'll see what that means more in just a sec. Okay, so the second section here is talking about classes. Now, classes are, here's what you think about a class as. It's a blueprint for a house. Okay, now our blueprint for a house is going to tell us that it's going to have a roof, it's going to have 4 walls, and it's going to have stuff. Okay, now it's going to be real generic on the stuff, and what I mean by that is it's going to, because we don't know what's going to be inside that house. We have fields that are going to set those parameters. For example, number of rooms, that's going to be a field. Square footage, okay, the size of those walls, those 4 walls, that all we know is a house has 4 walls. The size of those walls we don't know. The height of those walls we don't know. These are all things we don't know, because we're going, again, our blueprint is just 4 walls, rooms, we don't know how many, a roof, we don't know the pitch, we don't know anything, we just know that there's our blueprint. So now that's our class. Now, class we don't have direct access to. We don't use a class directly. What we do is we create an object from a class. So the class is our blueprint that we create an object from. So now I'm going to create a house object from this house class. And that house object, I'm going to then tell it it's going to have 4 bedrooms. It's going to have 2 bathrooms. Here's the dimensions of the walls. Here's the dimensions of all the different features, doors, all that. And now when I get done, I now have an object class of a specific house. I know how many rooms I have. I know how many windows. I know how many doors. I know how many, everything I have. Now that object, okay? And again, my class was sitting over here. It's just a blueprint. It allows me to create an object from that class. A class is just gives us the stuff that we can work with. So it's kind of like clay. It's the clay, and then our object, we actually form that clay into something. So that's kind of what they're describing here. Is we have a blueprint of a house, and then we build houses from the blueprint. Okay, a class is also it's also kind of like a cookie cutter, and what I mean by that is it allows us to create a house with this cookie cutter, cookie cutter, cookie cutter, but each cookie is not always going to be the same, because like I talked about before, is I can cookie cut this next house, but it's only going to have 3 bedrooms, 1 bathroom, and the walls are going to be smaller. I'm not going to have as many windows. So again, it's a cookie cutter stamp, but the cookies themselves are going to be a little different. So here I have an insect class. The insect class, now an insect, it has 6 legs, has a thorax, has all these different features, okay? But certain things we don't know about. So here's an insect class. The insect class is going to have just the things that an insect, the features an insect needs, okay? I can then create what's called a housefly object from this insect class. And what I'm going to do with that housefly object, I'm going to give it the features that just a housefly needs, nothing else. But all of the features, again, the blueprint of an insect is over here in the insect class, which means any insect can be created from this insect class. I can create a housefly object. I can create a mosquito object. I can create a praying mantis. I can create all the different insects from this class. It gives me just the basic features of an insect, and then I can get more detailed. And again, my fields and all that are going to basically be specifically set for that particular insect. So again, you're probably a little confused, but it'll probably make a little more sense here in a little bit. So how do we create a class? So far we've created modules, we've created functions, we've created all these different things. We created a main, we created just a regular procedural type of programming, but via pseudocode. Now we're going to create what's called a class. Okay, now a class again is our blueprint. We cannot basically use that class directly. We have to create an object from that class. A class is just a blueprint for us to create an object from. So what we do is we say class and we give it the class name. Then we put all the different fields and methods and things inside of there, and then we have our end class. Okay. So we're going to design a program for wireless solutions, a business that sells cell phones and wireless services. The program will use to keep track of cell phones that the company has in inventory. The data that we need to keep for cell phone is as follows: the name of the phone's manufacturer, the phone's model number, and the phone's retail price. Okay, so they're just 3 fields that we need for that class. Okay, so here's what it basically looks like. We have class cell phone. Now notice it says private, meaning what? Nobody outside of this class will have direct access to that field. I cannot outside of this class basically use manufacturer, model number, or retail price. So there's my class, there's my 3 fields. There's my ending class. Okay. Now these fields, I'm going to try to introduce this terminology now. Those 3 fields are what we call instance variables, meaning they are variables, they hold data, but they're instances to this object or this class that objects will be created from. Now this class is incomplete. Why? Because since those are private, nobody else can, basically nothing can use those. So this class is useless at this point. What we need are methods that allow us to manipulate those instance variables. So what we need is what are called setters. Okay, I was trying to see if they're talking about the other one. We'll see what they do here in a sec. But anyways, these are called setters. Notice I have set manufacturer, I have set model number, and I have set retail price. So what we do is now notice that the manufacturer, model number, and retail price, the instance variable themselves, always start with a lowercase letter. We always do that with instance variables. They're always lower, so they always start with a lowercase. Now, with setters, all we do, now we don't have to do this, but this is the guidelines throughout object-oriented programming, is we just put the word set in front of the instance variable name. So here I have set manufacturer, set model number, set retail price. Now notice that the manufacturer, or let's take a look at model number. So I've got set model number. Notice that model and number both have uppercase. This is what is called camel casting. It's easy to distinguish the three separate words there: set, model, and number. We do that by doing uppercase letters at the beginning of. Now again, notice that the S in set is lowercase, because we always have methods and objects, or I'm sorry, methods and instance variables are always start with a lowercase. Okay, so set model number, set retail price. Those are methods. Now if we come down here and look, so let's take a look at our class now. Now I have, so here's my instance variables: private string, private real. So there's 3 instance variables to this class. Nobody has direct access to those outside of this class. But now I have public module set manufacturer string manufact. So this is a module. We're passing something into it. We're going to pass in a string called manufact, and then inside of there it says set manufacturer to manufact in module. So now this is called a setter. It allows us outside of this class to now set that field manufacturer. I pass it a string. It then sets that field, that instance variable, to that string I just passed it. Here is public module set model number string mod num. Again, I'm passing a string. It then takes that string and sets the model number. Okay. Same thing for retail. Okay, it's a real. So we now have a way to set those particular fields. Now if you notice, how do we get access to those fields? How do I use those fields? Well, at this point we can't. We can set them, we just can't use them. So what we need now, well, let's take a look at what they're doing here. Okay, so I talked about setters. Now let's talk about getters. Getters are a way for us to now have access to those instance variables, the data inside of the instance variables. So here I have set manufacturer, set model number, set retail price. Getters are just the same exact thing as setters, except they start with the word get as opposed to set. So, and these are going to be functions. Why? Because they're going to return something. So if we notice, here I have public function string. That means it's returning a string. Get manufacturer. Notice there's nothing inside the parentheses. It returns the manufacturer. That's all it does. That's all a getter does, is return that instance variable via that function. Public function string, get model number, return model number. Public function real, get retail price, return retail price, and function. So it seems kind of strange, it seems kind of weird, but here's what we are doing as an object. I can now control who has access to that field and who basically can get data from that field. If you had direct access to the field itself, we would never ever know within our program where we were, because I could just say that particular class manufacturer is equal to this. Now within my program, within my functions, I don't know who has access to that. But with setters and getters, I now can control who has access when they have access. So in order to set manufacturer, to put data inside a manufacturer, they have to, they basically have to do this. They have to call set manufacturer and pass it data. It sets that field. If they want to get who the manufacturer is, they basically say, they call this function string, it's going to return a string, get manufacturer, and it returns the manufacturer. So now this is, I'm not going to call this a complete, but this class is usable. I can load data into it, I can get data from it. Now, I want you to think of this as now a black box. Think of it, we don't know what this code is about. Okay, it is just called an object called cell phone. It has manufacturer, it has model, has retail price. I know that I can load those data. I can basically call each one of those methods and load data into it, and then I can basically then call the getters to get the data out. Okay, so it's an object holding data. That's really what an object is all about. It holds data. We can load data into it, we can get data out of it. Now, here's what's great about this, and now here's what you think about. I can have a Galaxy S5 object. I can have a Turbo Droid object. I can have an iPhone 5 object. I can have an iPhone 6 object. I can have an iPhone 6s object. I can have an iPhone 7 object. So I can now have all these different objects, and when I get that object, guess what? I can now get that object's retail price. I can get the object's model number. I can get the object's who manufactured it. Okay, I have all that information now. So I have these different objects now that I can basically, oh, there's an iPhone 6s object. What is the retail price of that? And it will return the retail price to me. So now I hope it's making sense. And I've got these objects sitting out there that represent things. Okay, you've seen, I mean, houses are all kinds of different houses. We got ranches, we've got split foyers, we've got two-story, we've got tri-levels, we've got all these different types. But again, I can create each one of those houses from this house class. It gives me just enough, just the basics for a house, that I can create all these different houses from it. Again, like the insect class. The insect class has all of the basic features of an insect. We just need to modify each one of those to basically create our specific insect from. Same thing with our cell phone. I can create all these different cell phone objects from this class. This class, again, is my blueprint for creating objects. Okay. So here is, now, how do I, okay, now, I've got my object created, or I got my class created. How do I create an object from it? Well, here's how we do it. Is I want you to think of a class as like a data type. Okay, it's just like a data type. I declare something by using the class. So here is my module main, and I declare a cell phone. There's my class, and it's going to be called my phone. So cell phone is the class, my phone is now the object. Okay, I then come down here and I say set my phone equal to new cell phone. Now this seems kind of strange, and here's how I distinguish these. This guy just created a shell of a cell phone. Okay, so declare cell phone my phone. It's just a shell. It's just got an outer shell. That's all it's got. Do we know the instance variables? No. Do we know the methods? No. Do we know the functions? No. It's just a shell. This guy now set my phone equal to new cell phone. What this guy does is this now takes the instance variables, it takes the setters, and it takes the getters and loads them into that shell. Now we have an object. Okay, this is just a shell of an object. This is now an object that we can use. Because what we do, what's called instantiation. Instantiation loads the shell of an object with the guts. Instance variables, getters, setters, methods, whatever the case may be. All that gets loaded into when we do what's called instantiation. Okay? So this creates the shell, this loads the shell with data. Okay? Now, we have an object we can use. Does it contain anything? No, it contains nothing. So what we do is we call myPhone.setManufacturer. Now look at that. I've got a dot. So the object dot and the method name, that's just like calling the method. Okay. So what I'm saying is I want to call this set method, their set manufacturer method. I want to call that method. Where is it? Well, it's inside of myPhone. So I have to say myPhone dot. So I'm saying go to myPhone, go to the myPhone object, and then call the set manufacturer method. And what it's going to do, it's going to pass in the word Motorola. Call myPhone.set model number M1000. Call myPhone.set retail price $199.99. Now I have an object that has data in it. This is my Motorola object. What model number is it? It's the M1000. Okay? Has a retail price of $199.99. Now I can say display, the manufacturer is myPhone.get manufacturer. The model number is myPhone.get model number. The retail price is myPhone.get retail price. Now I probably would have surrounded that with the currency format function. But look at that. Here I set those fields. Again, I don't have direct access to each one of those instance variables. Why? They're marked private. My class, my object is controlled. I can control who has access, who doesn't have access. And so this created an object, a cell phone object. This instantiated it. Then we can call each one of those methods, the setters, to set the data. And then I can use the getters to get the data. Okay? And getters and setters are pretty much standard. We utilize those all the time. Now, there may be cases where I want to make my data read-only, which means I only have getters. I may want to make my object, the data is read or write only. I can't read it. I can only have setters. Okay, and we'll see what I mean by that, because I can have methods that do things with the data. I can have methods that set the data. I don't need setters. Okay. Again, this goes into what I talked about earlier. This creates the shell of an object. This then instantiates it. This is called instantiation. And it's whenever I have equal new, I always know that's an instantiation. It says create this as a brand new object and load all of the methods, all of the instance variables, all of the getters, all of the setters, all that gets loaded into the myPhone object. After that line executes, we now have an object that has instance variables, methods, getters, setters, the whole works. Now, the proper term, we're going to see this a lot here and in the next class, is getters and setters are also known as accessor and mutator methods. Accessor meaning I'm getting data, I'm getting the data. Mutator meaning I'm actually setting the data. I'm changing when I call a setter, I'm actually changing what's inside of there. I'm mutating it. Okay, so accessors and mutators, those are basically accessor, mutator is getters and setters. Okay. Different words, different meanings. Yeah, Yeah, and here, like here, mutator methods are sometimes called setters, and accessor methods are sometimes called getters. So if you see mutator, it's a setter. If you see accessor, it is a getter. Okay, so now we've talked about getters and setters, accessors and mutators. Now let's talk about this method. It's a special method. It's called a constructor. Okay. Now, it says a constructor is a method that automatically is called when the object is created. Okay. When is it called? We'll talk about that in just a sec. Okay. But let's take a look at an example of a constructor. So here I have my private string manufacturer, private string model number, private string retail price. Okay. Those are my three instance variables. Here's my constructor. Notice it says public model cell phone. Notice that this word is identical to this word. Very important. How can that be? How can a method have the same exact name? Notice the uppercase C, uppercase P. That always tells our class that that is the constructor. Notice that it returns model or module. It is a module. It doesn't return anything. So it is a module. Never ever is it a function. Constructors are always modules. They return nothing. In this case, I have string manufact, string model num, and real retail price or retail. Okay. So what it does is it takes that manufact and it says set manufacturer equals manufact, set model num equal model num, set retail price equals retail. So this method accepts two strings and a real, and it sets each one of those instance variables with the constructor. Notice I still have setters, so I can still set, but my constructor is also doing a setting. It's a setter as well. It sets all three. And then I have my getters. How does this work? Well, right here I declare my cell phone my phone. Again, I have a shell of an object. Is it an object I can use yet? No, it has no guts. I come down here, I say set my phone equals new cell phone Motorola, comma, M1000, comma, 199.99. The new, whenever you see the word new, that is the instance, that is instantiation. That also is calling the constructor method. Okay? Whenever we have new, the constructor method is being called. So back up here, when I do this instantiation, this constructor was called. I passed in the manufact, that set the manufacturer. I set the model num, that set the model number. I set the retail, that sets the retail price. Now, when I get done with line 9, I now have my cell phone object that now has data in it. I don't need to call the setters. My constructor did the setting for me. So now I can just say display the manufacturer is myphone.getManufacturer. Model number is myphone.getModel number. The retail price is myphone.getRetail price. The data is already there. Done. Okay, so the constructor is it's a really neat method. It lets us to kind of get things set up. So it's a way for us to set things up. In this case, we actually set those fields. Now, let's say I have this class just the way it looks right here for listing 14.4. It's got a constructor. I'm going to back up to this guy. Can I use this model main with that class? No, I cannot. And here's why. Because my constructor is expecting a string real. When I instantiate it, I have to pass in a string real. So right here on line 9 with my instantiation, it says new cell phone and there's nothing inside the parentheses. If this was a Java program, it would blow up saying, I'm expecting something because my constructor says I need to have a string real and you're passing me nothing, so I don't know what to do. Okay? The method, so again, think of this as a method right here. When I say new, so and think of this way. Anytime you have a name and parentheses, that is a method. And that is the constructor. Now, here's the rule of thumb with constructors. If I look at this class in 14.3 or 14-3, notice it doesn't have a constructor. Really, it does. It has an empty constructor. Okay? We don't see it, but it's there. It's always there. It's an empty constructor that does nothing, so we don't have to write it. So that is calling the constructor. Even if a constructor wasn't written, one is there. It just doesn't put it there because it doesn't have to. Okay, so we have getters and setters, accessors or mutators, and constructors. Constructors are only used once. They're only called once. We can never ever call them again. They're called once, only once, when it's instantiated. After that, they're not used anymore. Now, here I declare string manufacturer, model num, and I declare real retail. I declare cell phone phone. So I've created my shell of an object. Again, there's no guts in it yet. Then I display, enter the phone's manufacturer, enter input manufacturer. Display, enter the phone's model number, input model. Display, enter the phone's retail price, input retail. Now I have those three variables loaded with data. Now I say set phone equals new cell phone, manufacturer, model, and retail. Again, whenever I see something with parentheses, that is a method. That is the constructor that just got called. Constructors are always called with the new, okay, whenever it's instantiated. Now, I now have a my phone, phone. Yeah. I now have a phone object, which is a cell phone class. It's a cell phone class object. And it now has data in those three instance variables. Now I can use my getters to basically display all that. This right here it basically explains what I talked about earlier, default constructors. A constructor is always called. If it doesn't exist, it's still called. It does nothing. Okay. We could actually do something like this, where I could actually have. So this is a constructor, by the way. So let me do this real quick. I'll grab this class if I can. Now, I can do this. I can say public module cell phone left and right parenthesis end module. That is an empty constructor. Okay. Now you'll notice I have two constructors now with the same name. Is that legal? In this case it is. Here's what I want you to think about. What's inside these parentheses is what is called a signature. It's the signature of the module. In this case, this cell phone module has a signature of string string real. The signature of this cell phone object, or the cell phone method, is nothing. So if I had this class, I could use this main now. I could use this main because when I say set my phone equals new cell phone, empty parentheses, guess what? It's going to see if there's a module or a constructor that has no arguments. It's going to use that constructor at instantiation. The other one will just be ignored. I could also use this main to call that same class, because when I basically did my instantiation right here and I said new cell phone and Motorola M1000 199.99, it would look at the constructor and go, look, there's a constructor that has a string string real, I'll call that constructor. So it looks at the signature, what's inside the parentheses, it looks at the signature to see which constructor should be called, and it will do that automatically. So now this class can be used with either one of those mains. It's going to work either way. So with the first one, it's going to call that constructor, which does nothing, and then basically we can use our setters and our getters. The second main passes in a string string real, so it's going to call this constructor, which sets each one of those fields, and then we can use our getters. Now, here's another thing I want you to think about as well. If I have this constructor that has string string real in it, do I even need my setters? I could basically delete my setters and just use my constructor to do the setting. That's totally legal. Okay. So this next section gets into this thing called UML, or Unified Modeling Language. And the way, again, this is, I want to call it flowchart-like, in that it's basically using these diagrams to describe our classes. So in a real-world situation, what we would do is we would develop our UML before we would do our pseudocode. So we would say, okay, our class needs to have these variables, and they need to have these methods, they need to have these constructors, they need to have, okay, but it doesn't have any detail inside of each one of the methods. So what we do is we separate it into three sections. This is going to take this box and separate it into three sections. The first box is going to give us the name of our class. The second section is going to be our instance variables. And our third section is going to be all of our methods and functions. Okay? So here we have cell phone, we have manufacturer, model number, and retail price. Okay? And then here is our cell phone. Notice it's got the same exact spelling as our class itself, but it has parentheses around it, so that means it is a constructor. We have set, get. Now, we really don't have a whole lot to go with here. I don't know what the data type is for each one of these. I don't know which one's a function, which one's a method. So now let's take it a little bit further. Okay? So now I have manufacturer string, model number colon string, retail price colon real. Here's cell phone, left parenthesis, manufact string, model num string, retail real. Here's my set manufacturer, manufact string, set model number, model num string, set retail price, retail real. Now look at this guy, get manufacturer string, that says it's returning a string. Get model number string, it's returning a string. Get retail price real, it's returning a real. Okay, so now let's take this a step further. Now I have a minus sign manufacturer string. The minus sign says this is a private instance variable. Minus sign model num string, private. Minus sign retail price real, private. Plus sign says I'm public. Okay, so minus sign private, plus sign public. So now this is a UML that we can now utilize. I can give this to a programmer and they can actually create a class from this item. They can create a complete class. I know that the name of my class is called cell phone. I know it's going to have 3 instance variables: manufacturer, model number, and retail price, string, string real, and they're all 3 private. I'm going to have a constructor called cell phone. It's going to expect a manufact string, a model num string, and retail string. I'm going to have my set 3 setters. I have my 3 getters. Boom. I can create a class from that UML. Okay, so now let's take a real example now and let's basically write some pseudocode to create classes and objects. Okay, so one of the first steps when designing an object-oriented program is finding the classes that should be created and determining those classes' responsibilities in the program. Okay, so far we've learned the basic writing of a class, creating an object from a class and using the object to perform operations. Although this knowledge is necessary to create your object-oriented application, it is not the first step. The first step is to analyze the problem that we're trying to solve and determine the classes that we will basically need. And when we talk about classes, we're talking about instance variables, we're talking about methods, we're talking about all of those things. So, the owner of Joe's Automotive Shop has asked you to design a program that will print service quotes for customers. You decide to use an object-oriented approach to design the program. One of your first tasks is to identify the classes you will need to write, that you will need to create. In many cases, this means identifying the different types of real-world objects that are present within the problem and then creating classes for those types of objects within your program. Over the years, software professionals have developed numerous techniques for finding classes within a problem. So we're going to read this narrative and try to figure out what's a class, what's a method, what's an instance variable, all that type of thing. So it basically involves these steps. Get a written description of the problem, identify the nouns in the description. Each of these is a potential class, and refine the list to identify only the classes that are relevant to the problem. So we're going to read this following narrative and we're going to try to get the physical objects such as a vehicle, machine, and products, roles played by people such as a manager, employee, customer, teacher, student, so on, the results of the business event such as a customer order or in this case a service quote, record-keeping items such as customer histories and payroll records. So here is the description of Joe's Automotive Shop. Joe's Automotive Shop services foreign cars and specializes in servicing cars made by Mercedes, Porsche, and BMW. When a customer brings a car to the shop, the manager gets the customer's name, address, and telephone number. The manager then determines the make, model, and year of the car and gives the customer a service quote. The service quote shows the estimated parts charged, estimates the labor charges, the sales tax, and total estimated charges. So, First thing we got to do is go through and identify all of the nouns. So we do that, and we have so that the ones that are bolded are the nouns, and then we take those and bring them down here, and we have address, BMW, car, cars, customer, estimated labor charges, estimated parts charges, foreign cars, Joe's Automotive Shop, make, manager, Mercedes, model, name, Porsche, sales tax, service quote, shop, telephone number, total estimated charges, and year. So now let's refine those because we're going to see some duplication here. We know that cars and foreign cars are basically the same thing. We know that Joe's Automotive Shop and shop are the same thing. Okay. Let's skip that. So basically what they did is they got rid of foreign cars and Joe's Automotive Shop. And then because cars and foreign cars mean the same thing, we've all eliminated foreign cars because Joe's Automotive Shop. Okay. Some things might represent the same thing as well. So we can cross shop off the list because our application only needs to be concerned with the individual service quotes. Okay. We do not need a class for manager. Manager really has nothing to do with our service quote, so we can get rid of that as well. Some of the nouns might represent objects, not classes. We can eliminate Mercedes, Porsche, and BMW because these are going to be objects that we are going to create from a class. Okay, so we're going to have a car class. We're going to create a Mercedes, which is created from the car class. Does that make sense? So we're not going to have a Mercedes class. We're not going to have a BMW class or a Porsche class. Those are going to be objects. We're going to create a Mercedes class from the car class. We're going to create a Porsche. Remember we talked about the iPhone and the Galaxy S7s and all that created from the cell phone. Same thing here. I got a car class. I create a Mercedes object from that. I create a Porsche object from that. Cars and cars are the same thing as well. So we can get rid of BMW, we can get rid of car, we can get rid of foreign cars, George, manager, Mercedes, Porsche, and shop. Okay. Some of the nouns might represent simple values that can be stored in regular variables. Okay, so our instance variables. So address, estimated labor charges, estimated parts charges, make, model, name, sales tax, telephone number, total estimated charges, and year. Those are all instance variables. Those aren't objects or classes. Those are variables inside of the class. So we get rid of all those, and then we're down to cars, customer, service quote. So now those are the three classes we need to make. Okay. So now the customer class. What do we need? What instance variables do we need for our customer class? Well, we take a look at all of the nouns that were in that particular verbiage we saw up above, and we're going to need the name, address, and telephone number. Those are all going to be instance variables for the customer class. So what do? Is I'm going to create my UML for the customer. So here's customer. Name is a string, address is a string, and phone is a string. Notice they're all private, the minus sign. Here is my constructor. Notice it's got the same exact spelling as my class. Customer. I got N, which is a string, A, which is a string, and P, which is a string. So name, address, and phone number. I got my setters. I got my getters. Notice everything's got a plus sign, so it is public. Here's my customer class. Private string name, private string address, private string phone. Here's my constructor. Public module, customer, string N, string A, string P. So inside of my constructor, I'm going to go ahead and do my setting. So I set name equals N, address equals A, and phone equals P. So when I instantiate this class and I pass in those three variables, it's going to automatically load those three instance variables. And I have my setters and my getters. Okay, so the car class. Well, if we look at the nouns up above, we know that make, model, and year are going to be instance variables for our car class. So there's my make, model, year, there's my constructor, there's my setters and getters. Here's what that class looks like. Private string make, private string model, private string year. Or I'm sorry, integer year. You're going to do integer. Public module car, we're going to pass on a string, integer. We go ahead and set those three variables, instance variables. Here's my setters, there's my getters. Here's my service quote class. Looking at the variables up above, there's two variables I need, instance variables, parts charged, labor charges. They're both going to be real. Here's my service quote constructor, and I got PC real and LC real. And there's my setters and my getters. Here's the class. Private real parts charges, private real labor charges. Here's my constructor. Notice it's got the same exact name as my class up above. Public module service quote, real PC, real LC. So I pass in two reals and it sets those two fields. There's my setters and my getters. Okay. And the service quote, now notice down here. I want you to pay close attention to this class. It doesn't have just getters and setters. It has a little bit more. So here's my mutators. These are my setters. Here's my accessors. These are my getters. But notice I have public function real get sales tax. I pass in real tax rate. So I pass in the tax rate, and then it says return parts charges times tax rate. So this guy is going to return the sales tax. So when this function is called, it returns the sales tax. Then I have public function real get total charges, and I pass in the tax rate. I return parts charges plus labor charges plus get sales tax rate. Wow, look at that. I am calling this method or this function right here. So this guy is calling that function. It passes the tax rate, it gets the tax, it then adds the parts charges, labor charges, and the tax, and it returns the total charges. Pretty cool. So look at that. I can have one function call another function. Okay, now these next two sections are kind of deep, and in fact we won't see these I think until the Java 2 class. But we want to introduce them here so that you kind of have an understanding of how they are. Okay, so we saw earlier that we have an insect class, and I can create a bee and a grasshopper. They're both insects. Well, look, one has wings, one has big back legs, one has a stinger. Okay, one has the ability to jump. Okay, they're both insects. Totally different as insects. So what this is I have this insect class, and I'm going to create a bee class and a grasshopper class from those. What I can do is this thing called inheritance, okay? Because we can say, and that's called an is-a relationship. So my grasshopper class can inherit from the insect class because a grasshopper is an insect. A bee is an insect. I could have a dog class, and I could create a poodle class from that. A poodle is a dog. I could have a vehicle class. I could create a car from that vehicle class. I could create a truck from that vehicle class. Okay, I could create all these things from that vehicle class. A flower is a plant. A rectangle is a shape. A football player is an athlete. Okay, so this insect class is what is known as a superclass, and I can create my class and inherit everything from that superclass. So So here I have a class called graded activity. I've got a private instance variable called score, and it has a real data type. I have a get scores, set score, which I pass in an S, which is real. I have a get score, which is a real, and I have get grade, which is a string. Okay. Now, this is the framework for creating a class. So let's take a look at what the class looks like. So if I create a class from this UML, again, this is all pseudocode, I have class graded activity. I have private real score. I have public module set score, and I'm going to accept a real called S. I set the score equal to S. Okay, so there's my setter. Here's my getter. Public function real, get score. All it does is return score. Notice that it's returning a real. Okay. Here is my get grade. So this is a function. It returns a string called get grade. I'm passing nothing to it. Declare string grade. There's an empty string or empty variable called grade. String data. If the score is greater than or equal to 90, then set grade equals an A. Else, if score is greater than or equal to 80, set grade equal B. If score is greater than or equal to 70, then set grade equals C. Else, if score is greater than or equal to 60, set score to D. Else, set grade equal F. Okay, and it returns grade. So when I create this an object from this class, I can set the score. Then I can just say get the grade, and it automatically goes, hey, I know what the score is. I can then give you the grade, and it basically will give that depending on what score was basically entered. So here's my main. I declare real test score. I declare graded activity test. So here is my class graded activity. Here's my object test. Right now I just have a shell of an object. It's not been instantiated yet. So here's set test. There's my object equals new graded activity. Again, there's my constructor that was called. If I go up here, was there a constructor? No. But remember, if no constructor is written, one is basically written for us. Okay. So now I have a test object. I then say display, enter the numeric test score, input test score. I say test.setScore equals test score. Okay. So whatever the user typed in here gets loaded into score. Then I display the grade for the test is test.getGrade and returns a grade. So if it's typed in 89, the grade for that test is a B. If I typed in 75, the grade for that test is a C. Okay, so now I have graded activity. It's a class. It has the basics that I need. It's got score, it's got get grade. Now I've got final exam. It's got num questions integer, points each real, num missed integer, all minus signs, which means they are private. I've got a final exam, questions integer, missed integer. So here is my constructor, and it's expecting an integer, which is the questions and missed. And then it's got get points each. It's going to return a real, get num missed, and returns an integer. Now, I want you to look at line number 1. It says class final exam extends graded activity. Whoa, what's going on here? This is called inheritance. It says this final exam is a graded activity. So everything in graded activity is now inside of here. Do I see get grade? Do I see score? Do I see set score? No, I don't. They're there. How are they there? Because I inherited them up here. They're automatically there. But I've added 3 more variables. And I've added, look, how many more modules and functions have I added? This is what's known as polymorphism. Okay, my object, when I have my instance variables and I have my getters and setters, all of those are inside of that object. Again, when we talked about the black box, I don't know what's inside of there. That's called encapsulation. It has instance variables, it has methods, it has constructors, has all those things encapsulated inside of it. That's called encapsulation. Polymorphism now says I'm creating an object from another object. Right now they're identical until I add 3 new instance variables and a bunch of new methods and functions. Now I've changed it a little bit. Polymorphism. So poly meaning many, and morph means change. So many changes. So I've actually changed that object into this new object called final exam. So now I have my 3 private instance variables, num questions, points each, and num miss, which is integer, real integer. Here's my function, which basically does the setting. Now look at this. Inside of my function, I create a local variable called numeric scores. I set num questions equal questions. I set num missed equals missed. So those are my setters. Think of it as my setters inside of the constructor. But then I say set points each equals 100 divided by questions. Okay? So I am actually doing a calculation to figure out points each. Because I might only have 89 questions, but my test is worth 100 points. So now I take 100 divided by the questions. That's going to tell me how much each question is worth. Then I set the numeric score. So here's my numeric score that I just created up here is equal to 100 minus missed times points each. So now think about it. I now know how much each question is worth. I then multiply that times the number of questions I missed, and I subtract that from 100. That is my numeric score. Then I come down here and I call set score equals, or set score numeric score. Where is set score right here? I don't see a method called set score. Remember we inherited graded activity. Set score is in graded activity now to us. To final, is it called final exam? Yeah. To final exam, graded activity is our superclass. When I call set score, it's calling that set score within our superclass, and it's setting that score. Okay, there's my 2 getters. So now, here's my main. I declare integer questions and missed. They're both integers. I declare final exam, exam. So there is my object. Remember, it's a shell of an object. It doesn't have any guts yet. Not until I do what? Until I instantiate it. Then I display, enter the number of questions on the exam, input questions. Display, enter the number of questions that the student missed, and then input missed. Now I instantiate final exam. So set exam equals new final exam, questions and missed. So now that function is called. So what happened? Well, we passed in the number of questions and how many they missed. I declare this real numeric score. I set num questions to questions. I set num miss to miss. So now those 2 instance variables above have data in them. I set points each. Again, points each is also an instance variable above. I set that equal to 100 divided by the number of questions. So now I know how many points each question is worth. Then I set the numeric score is equal to 100, that's the possible points, minus missed times points each. I now have this numeric score. Then I call the set score, pass in a numeric score, which is it's my method in my superclass. So now, I now have an object that has data in it. Now I can say, display each question on the exam is worth exam.get points each, points. Display this exam score is exam.get score. Display the exam grade is exam.get grade. Where's get grade? It's on our superclass. Remember that? It's on our graded activity that we inherited from. We polymorphismed that into final exam. Okay. This is what a UML document looks like when we have an ISA or an inherited relationship. Final exam says I am, notice it's got an empty triangle arrow pointing to graded activity. So this is the superclass, this is what's known as the subclass. Okay? Everything graded activity has, a final exam has as well. I can't stress this enough, inheritance does not work in reverse, meaning graded activity does not know anything about final exam. It knows nothing about it. This is a one-way arrow. Final exam has everything graded activity has, but graded activity doesn't know anything about final exam. Okay, so I kind of talked about polymorphism a little bit. Let's take polymorphism and I kind of step it up a little bit. So it allows us to create methods with the same name in different classes. Okay, so here I've got a class animal. Let's jump right into it. It'll help explain it. So I've got this class animal, and it has a public module shows species, and it says I'm just a regular animal. Public module make sound, display GR in module. So this is just a class animal, has just two methods in it. I declare an animal my animal. I instantiate it by saying set my animal equals new animal, and then I call my animal.showSpecies, call my animal.make sound, and it would say I'm just a regular animal, GR. Okay, so now let's talk about polymorphism. So now I have class dog extends animal. So again, my superclass is animal, my subclass is dog. Now, I have public module show species, display I'm a dog. Whoa, 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 whoa. This has show species. Well, this one has show species as well, but it says display I'm a dog. It also has make sound, display woof woof. So now I come up here and I say declare dog my dog. I instantiate it as a new dog, and I call my dog.showSpecies, my dog.make sound, I'm a dog, woof woof. So if we basically rewrite a method with the same exact name, we are basically changing that method of our superclass. Again, the polymorphism, we're going to take that just a step further by changing it, the actual method itself. We can do the same with a cat. Cat extends animal. Show species, make sound, two different items there as well. So here we have declare animal my animal, declare dog my dog, declare cat my cat. So again, utilizing those three classes up above. And again, realize my dog and my cat both inherit or extend my animal. Set my animal equals new animal. Set my dog equals new dog. Set my cat equals new cat. Display here is the information about the animal. Show animal info my animal. So down here I go to show animal info. It's going to return a module. I'm sorry. Let's see what they're doing here. So, so we got module show animal info, animal creature. So it's accepting the class animal and we're gonna call it a creature. Again, remember, we're passing by value now. We call creature, show species, call creature, make sound. So down here I can say, display here is the information about a dog. Show animal, my dog. Show animal, my cat. Show information, my animal. So we can call the same exact method for each one of those objects. But notice it's passing in animal. But up here I have dog, my dog and my cat. That's because those extend the animal class, so they are also an animal. Remember, a dog is an animal, a cat is an animal, because we extended it. So even though this is animal, it will still accept the dog class and the cat class. And when it says show species, it's going to show dog, and it's going to say woof woof. When it says show species, it's going to say cat, and when it says make sound, it's going to say meow meow. And there they are. Okay, so that's it for that chapter. Again, if you have any questions, give me a call. Be glad to answer any questions you might have.